Well, this is, I think, about as good as I can do by hand. I think that the valve reliefs are as preserved as they can be. Give you an idea, although it's chewed up all around it. Here is an example. This bottom edge here is smoothed out as best as I could using, again, the tools that I have here. I'm gonna go ahead and run some lapping compound on it and see if I can clean up those seats just or reliefs a little bit better, but amidst the damage I think we'll still get a decent seal. Looking at the other side, you can see that those reliefs are pretty clean as well. Sometimes it can be misleading about, you know, all the damage around the edge, and like this is about how it will sit. So you can see that all of the trimming, shaving, all the metalwork around the edge, really what we're trying to achieve is more consistent airflow out of the valve as the cam opens. By having these little sharp edges, raised parts, and then flat spots where, you know, it was dented in, kind of like this edge was, it creates varying restriction. Then instead of having a consistent airflow, example, around the valve, this is a low spot, you'll have more flow at this, and then you get worse intake charge or exhaust flow out the other side. Ideally, you want uniform airflow around the edges of the valve so you don't get any hot spots. Although you probably wouldn't notice too much on a low compression 125cc engine like this. Over time, essentially, you'll burn the valves up, have hot spots, and then you'll have, you know, top end failure. I'm going to go ahead and clean this up a little bit more, try and do a little bit of hand polishing with some steel wool just to kind of clean up any sharp edges. Then we'll start putting it back together and see what happens.